Hello everyone. Uh, Hello everyone, and yes, I hope that I am live. Yeah, and I hope my audio and video is clear. So I welcome you all to Amix Live, and in this series, we are dealing with fluid mechanics SSCJE previous year's questions. Already we have discussed the first chapter, and also we have started with the second one, pressure measurement and hydrostatic forces, and we have completed around 25 questions of the first chapter, and today I am going to complete this second chapter as well. तो आज हम लोगों का प्रेशर मेजरमेंट खत्म होने वाला है एंड फिर हम थर्ड चैप्टर जाएंगे कल। तो आज भी कुल मिला के कुछ 20-25 क्वेश्चंस है। So let us start. So obviously welcome you all to Amix Live, and this is fluid mechanics SSCJ previous year's questions. Obviously this is a chapter wise course, and here we will be solving previous year's questions of not only SSC but also state PSCJE, as well as obviously some objective point of view of the semester as well. So it will be helping you to to clear your concept through questions, as well as it will be helping you if you have already completed the syllabus. It will help you to revise the subject in a very detailed manner, right? So let us start with the first question of the second chapter, that is hydrostatic pressure and pressure measurement as well. So this is the first question of today's class. The question is saying us that a rectangular plate of dimension 1.25 meter by 2.4 meter is immersed in a liquid of relative density is given by 0.85, right? And with its 1.25 meter side horizontal, okay, and just at the water surface, if the plane of the plate makes an angle भी दिया है 60 degree, तो प्रेशर फोर्स वन साइड ऑफ द प्लेट इज प्रेशर फोर्स निकालना है. We have to calculate the pressure force. So the question is given like this is water level, this is the water level, and this is a plate is given like this. That is how the plate is given, right? And if I want to see the top view of the plate, how we can see this? The top view must be like that. Actually the plate is like that, and here the pressure is actually exerting. So this is the top view. Basically this is the top view, right? So that is how actually I am showing in this case. In this case I am showing you like that, okay? But when you will see this from this side, आप अगर ये वाटर लेवल है तो इसको अगर इस साइड से देखोगे तो आपको सिर्फ ये वाला विड्थ दिखेगा, जो ये मैंने ये वाला चीज दिखेगा सिर्फ आपको. दिस इज नथिंग बट दी विड्थ. ठीक है. यस. सो ये दिया है डेटा कि दिस इज 1.25 मीटर, this is 1.25 meter, and this is 2.4 meter. Obviously this is 2.4 meter, so this is the CG of this body, right, which is 1.2 meter from the surface. Okay, so if I want to calculate the horizontal distance from the surface to the CG, it is, let us name this as x bar, and this is y bar, which is 1.2 meter is named as y bar, and this is the angle which is 60 degree. So we need to calculate here the pressure force. So pressure force is For a hydrostatic force for inclined plane, the pressure force is rho g a x bar. So this is the formula for the pressure force, rho g a x bar, right? So x bar we have to calculate. Now let us take this particular body. If I take this is x bar, this is our y bar, and this is 60 degree. So what is sine theta? Sine theta will be opposite to hypotenuse, x bar upon y bar. So if I want to calculate the x bar will be y bar sine theta. Now what is x bar in this case? This is y bar is given as 1.2 meter, so it is 1.2 into what is sine 60 degree. In this case, the angle, the theta is given as 60 degree, so sine 60 degree will be, the x bar will be coming out as 1.04 meter. So this will be coming out as x bar. Now what is the area of the body? The area is 1.25 into 2.4 meters square, which will be coming out as 3 meters square. I hope it will be coming out as 3 meters square. Yes, it is coming out as 3 meter square, and this is water. Sorry, the row of water is 1000, and specific gravity of this liquid is given as, the relative density is given as 0.85. So what will be the rho of this liquid? 850. Now let us calculate the pressure force. It is 850 into 9.81 into the area 3 meters square into x bar, which is 1.04. So what will be the pressure? It will be coming out as so it will be coming out as 26016.12, and this is Newton. But the options are given in kilonewton. So this is something 26 kilonewton is the answer, which is somehow close to this answer. So we can write this as approximately this is 26 kilonewton. So this is the solution. For the first question, we have the answer as 26 kilonewton. Okay, I think this would be clear to all, and let us move to the next question. Okay, this is the second question, and the question is saying the relationship between atmospheric pressure and gauge pressure and absolute pressure. What is the relation between? So I have already discussed in the previous class that what is the relationship between atmospheric pressure, gauge pressure, and absolute pressure. So let us name this as absolute, and let us name this as P atmospheric. So if I have to measure, let us go to the next page. So what is this? This is absolute zero pressure. Absolute zero pressure. So this is the absolute zero pressure, and this is P atmospheric. If I have to measure any point or any pressure at that point, and if I start measuring from this, suppose I have measured this, and this will be called as P absolute. And if I measure that same point, if I measure with the respect or with respect to P atm, atmospheric pressure, now it will be called as P gauge. So for gauge pressure, the datum is atmospheric pressure. Okay, so the relation is coming out as P absolute is equals to P ATM plus P gauge. Now in this question they are saying us that is it P ATM is equals to P absolute minus P gauge. Option B is giving us P absolute is equals to P gauge minus P ATM. So this is not possible, as P absolute is equals to P gauge plus P ATM. So this is wrong. Now same here, it is also wrong. Now it is given as P atmosphere is equals to P absolute plus P gauge. Is it right? No. P absolute is equals to P ATM plus P gauge. If I need to calculate the P atmospheric, so we have to we have to send this P gauge to the left hand side, so it will be coming out as P absolute minus P gauge. So this is also the wrong answer. The right answer is P atmospheric is equals to P absolute minus P gauge. This is the right answer. So P atmospheric is equals to P absolute minus P gauge. This is the right answer for the second question. Let us go to the next question. This is saying us the center of pressure on an inclined plane is. Center of pressure ये जानना चाहते हैं कि एक्स सीपी, इसको सेंटर ऑफ प्रेशर बोलते हैं. तो एक्चुअली सीपी सेंटर ऑफ प्रेशर सीपी सीपी बोल रहा है कि इट इज एट सेंट्रॉइड सीजी में है, या अबव सेंट्रॉइड, या सीजी से ऊपर आएगा, या सीजी से नीचे आएगा. ठीक है, तो let us check this question. Already we have discussed that for, okay, let us draw again. Let us draw another figure. This is the surface, and let us suppose, or let us assume that this is the inclined plane or inclined surface, right? So if the center of gravity is at the middle, so if this is total if x, so this is x by 2, right? Now what will be center of pressure? Center of pressure कहाँ पे आएगा? ठीक है, तो center of pressure ऑब्वियसली द प्रेशर जो काम कर रहा है इस बॉडी में वो लीनियर नहीं है, वो सब जगह एक नहीं हो सकता. क्यों? द फर्स्ट थिंग दैट इफ दिस डिस्टेंस इज x1, so what will be the pressure at that point? It will be rho g x1, and obviously as the fluid is in static condition, इस फ्लूइड में शियर स्ट्रेस नहीं आ सकता, एंड टू फॉर दैट रीजन ये फोर्स कभी ऐसा नहीं आएगा. Because if the force is coming like that, if the pressure is coming like that, so it will have definitely a shear component, so it will be acting as shear force, which actually is not possible. So as it is a static fluid, all the pressures will be normal to the surface, and the definition of pressure is only that the external normal force upon area. So this will be the pressure. This will be the pressure for that surface, that particular body. Now this height or depth is x1. Let us name this as x1. So what is this depth? This depth will be x2, and definitely x2 will be greater than x1. So if I want to calculate the pressure at the last point, it will be coming out as rho g and x2, because rho and g will be constant, so it will be varying, the pressure will be varying with respect to the height or the depth, which is x1 or x2. So x2 is greater. Now I can say that this pressure at point 2 is obviously greater than pressure at point 1. So the velocity profile is not linear, it is not same everywhere. So the not the velocity profile, the pressure profile. Hello Vigyan, hello. So the velocity is not the velocity, the pressure is not same everywhere, it is varying with the depth. So if the pressure is varying with the depth, so we can say that the point of pressure will not be at the center. It is very obvious that the point of center of pressure is not at the, if this is the CG, this is the CG, and if I want to draw the pressure distribution, this will be somehow like that. So this is the pressure distribution, right? So you can see the pressure intensity is somehow greater in the bottommost part. So this, I can say that the center of pressure will be obviously at the bottom side of the surface. So it will be, but the CG of the surface is at the middle. So obviously the center of pressure will be below than the center of gravity. That is, it will be below centroid. Option C will be the correct answer. And still we have some mathematical approaches also, that in the previous question I have solved you that xcp, that is the vertical distance from the surface to the center of pressure, is equals to x bar. What is x bar? X bar is the vertical distance from the surface to the centroid, plus that is the moment of inertia upon a into x bar sine square theta. So if I want to calculate the difference between Cp and Cg, I need to calculate the xCp minus x bar. That is how we can calculate the vertical distance between these 2 points, and this will be coming out as Igg by a x bar sine square theta. So you can see that by subtracting xCp from x bar from xCp, we are getting this value. So that is how we can say that xCp has a greater value than x bar. Obviously, that is the that proves us that xCp will be greater than xg, and greater in what manner? Greater in the vertical distance manner. So if the vertical distance from the surface to a point is greater than another point, so we can say that it is the greater point is below the lesser point. So this is the right answer for the question. It will be below the centroid. Okay, so let us go to the next question, and it is saying us the total pressure on a surface of vertical sluice gate 2 meter by 1 meter with its top 2 meter surface being 0.5 meter below the water level. So total pressure we have to calculate. Now let us draw the water surface. So this is the water surface, and this gap is 0.5 meter, I hope. Yes, the gap is 0.5 meter. This 2 meter is saying that 2 meter surface its top. So this is top and this is 2 meter, and this is 1 meter, right? So this is 1 meter. So what will be the CG? CG will act at the middle of the width, so it will be coming out as 0.5 meters. So if I want to calculate the x bar, which is the vertical distance, it will be coming out as 1 meter. And we have to calculate the pressure intensity, that is rho g a x bar. It will be, for water, this is 1009.81. What is the area? The area is 2 into 1 meter square, and this is 1, the x bar is 1 meter, and if I calculate, it will be coming out as 20,000 Newton. So, but the unit is on kg, so it will be 2000 kg. Option D is the right answer. It is how is coming as approximately 20,000, because this we have considered the G as 9.81, but it is not given in the question. But after seeing the option, you can assume the G as 10. So if we assume the G as 10, then it will come out as 20,000 Newton, and which will be equal to 2,000 kilo, right? So this is the right answer for the fourth question. Now this is the fifth question. Is saying us the longitudinal rectangular surface is hanged into the water such that its top and bottom points are at depth of, top point is at a depth of 1.5 meter and the bottom point is at depth of 6 meter respectively. So the depth of pressure from the top surface is, so ये depth of pressure मतलब we have to calculate HCP. But at first let us draw the surface. Wait, just a second. Let us draw the surface, and it is given that the distance of the first point or the top point from the surface is 1.5 meter. It is given that 1.5 meter from the surface and the bottom point is at the distance of 6 meter. That means the height of the rectangle is 4, sorry, not 4, it will be 3.5 meter. 6 minus 1.5 meter, that will be 4.5 meter. Right, so it will be 4.5 meter. Now what will be the CG? If this is the CG, so this will be coming out as, what is this? If this total is 4.5 meter, so the CG will be half of 4.5 meter, that is 2.25 meter. But I have to calculate this from this top surface. So we basically need the x bar. So if I want to calculate the x bar, so this will be, already this is 1.5 and this is 2.25. So it will be 2.25 meter plus 1.5 meter, and it will be coming out as 3.75 meter, and we have our x bar, right? Now the area of the rectangle, this is 4.5 meter, it is given to us, but this is not given, so let us take is as B. Okay, now let us calculate the XCP. If I want to calculate the center of pressure, XCP is according to the formula x bar moment of inertia A into x bar sine square, and this is a vertical case, so it will be 90 degree. For vertical, the sine theta, the theta is theta is replaced as 90 degree. Okay, now let us calculate what is this. This is B d cube upon 12. Now B is not known to us, so let us take this as B. B is known to us actually, so we have to calculate 4.5 cube by 12. And what is the area? The area is B into D. So 4.5 into B is the area. Now x bar is 3.75 plus this is B into 4.5 whole cube upon this will be B into 4.5 and this is 3.75 and sine 90 is 1, so it will be 1. And if I calculate the XCP, it will be coming out as, so yes, BB will be cancelled out, so just 4.5 here whole cube and it is 4.5 into, my god, I have forgotten this 12, that 12 is also there, so 12 into 3.75 and it is coming out to be, yes, it is coming out as 4.2 meter. So this is the right answer, option B. 4.2 meter will be the center of pressure. Now the next question, the pressure intensity is same in all direction at a point in a fluid. कब प्रेशर इंटेंसिटी एक फ्लूइड में ऑल डायरेक्शन में एट ए पॉइंट विल बी सेम, वी हैव टू कैलकुलेट. ठीक है, तो प्रेशर इंटेंसिटी कब सेम होगा, ओनली व्हेन द फ्लूइड इज फ्रिक्शनलेस एंड इनकम्प्रेसिबल, ये तो आइडियल फ्लूइड वाला केस है. ठीक है, सेकेंड, ओनली व्हेन फ्लूइड इज फ्रिक्शनलेस एंड इज एट रेस्ट. ओके, only when fluid is frictionless, and option D is when there is no relative motion of one fluid layer relative to other. This will be the correct answer because the fluid has to be in static condition. You need to have the fluid in a static condition, and when there is no relative motion of one layer of fluid to another layer, that means no shear is required. So when the fluid is in static condition, there is no shear in that particular fluid. So it will be option D. No relative motion should be there between the layers. The seventh is saying that the atmospheric pressure with rise in altitude decreases linearly, first slow then steeply, and this is obviously option B. So if you draw this, you will find like this, first slowly then steeply. Okay, this option B is the right answer. The next question, as the depth of immersion of a vertical plane surface increases, the location of center of pressure. वर्टिकल कोई प्लेन को अगर और भी हम डेप्थ को इंक्रीज करें, ठीक है, तो उसका सेंटर ऑफ प्रेशर कैसे चेंज होता है. The option are given as falls closer to the center of gravity, moves away from the center of gravity, ultimately coincides with the center of gravity. None of this. Ultimately फॉल करता है जब हॉरिजॉन्टल केस होता है, वर्टिकली में नहीं. हॉरिजॉन्टल में जहां सारे प्लेन में जो प्रेशर है वो सेम लगता है, तब एक ये कोइंसाइड करता है. मूव्स अवे नहीं हो सकता क्योंकि जब डेप्थ इंक्रीज होगा, विद द इंक्रीजमेंट ऑफ डेप्थ ये भी प्रेशर बढ़ रहा होगा, टॉप का भी बॉटम का भी प्रेशर बढ़ रहा होगा, और डेप्थ में ये भी और बढ़ जाएगा, ये भी और बढ़ जाएगा. ठीक है, तो इट विल फॉल समहाउ क्लोजर टू द सेंटर ऑफ ग्रेविटी, ये थोड़ा ऊपर ऊपर आने लगेगा क्योंकि जब दोनों का प्रेशर इंक्रीज होगा तो ये सेंटर ऑफ प्रेशर जो है वो धीरे धीरे थोड़ा ऊपर आएगा, लेकिन कोइंसाइड नहीं करेगा. कोइंसाइड करता है जब हॉरिजॉन्टल होता है, सब में प्रेशर इक्वल होता है, तभी कोइंसाइड करता है. ठीक है, सो ऑप्शन ए विल बी द राइट आंसर. So this is the question. If mercury in a barometer is replaced, hello Vikram. So हम लोग अभी सेकंड चैप्टर की बात कर रहे हैं जो प्रेशर मेजरमेंट है। तो पिछले क्लास में हमने ऑलरेडी प्रेशर मेजरमेंट के काफ़ी सारे क्वेश्चंस कर लिए थे। तो आज बाकी के क्वेश्चंस कर रहे हैं। तो आज प्रेशर मेजरमेंट वाला चैप्टर, उसके साथ हाइड्रोस्टैटिक फोर्स, ये एक साथ दोनों का क्वेश्चन कर रहे हैं हम। तो ये दोनों आज खत्म हो जाने वाले हैं। ठीक है, आज 20 क्वेश्चन है लगभग। तो सारे के सारे क्वेश्चन आज खत्म हो जाने वाले हैं। So, okay, the question is saying us that if the mercury in a barometer is replaced by water, the height of 3.75 centimeter of mercury will be following centimeter of water. Already I have discussed that theory yesterday. Rho 1 H1 is equals to rho 2 H2. So in this case, the mercury, the height of the mercury is given as 3.75. So let us name this as rho Hg into H of mercury is equals to rho of water, because we are replacing that by water, right? Yes, so rho of water to the height of water. So this is 13,600 into, this is given in centimeter, right? 3.75 centimeters. So it will be 0.0375 is equals to, we have to convert that on meter, and this is 1000, and HW we need, and it will automatically coming out in the form of meter. So HW will be 13.6. if this 1000 is cut by 13,600, it will be coming out as 13.6 into 0.0375. So which will be the right answer between these four options? Let us check. So 13.6 into 0.0375, and this is coming out to be 0.51 meter, which is 51 centimeter. Let us check the options. Option A is the right answer, 51 centimeter. So this is the right answer. Let us come to the next question. If W is the specific weight, what is specific weight? Rho into G. Specific weight of a liquid, and H is the depth of any point from the surface. So this is surface, this is the H, this is the rho, and G is constant. So what will be pressure intensity? The pressure intensity will be rho G H. So this will be W H. So option B, W H is the right answer. The next question, the pressure of 200 kilopascal is equivalent to the head of Z meter of liquid having relative density of 1.59, the value of J. इसमें क्या है, हम लोगों को रिलेटिव डेंसिटी दिया हुआ है। तो इसका मतलब है कि डेंसिटी ऑफ दैट लिक्विड अपॉन डेंसिटी ऑफ वाटर is equals to 1.59. So what will be the density of that liquid? Will be 1590. So we have the rho, we have the pressure intensity, and we need to calculate the height, that is in Z meter. So let us calculate. P is given as 200 kilopascal. Z we need to calculate. Rho is given as 1590. 1590, yes, 1590. So what is pressure intensity? That is rho into G into Z in this case. So this is 200, and if I want to calculate in Pascal, it will be 10 to the power 3, and this is 1590 into 9.81 into Z. So Z will be 9.81, and Z will be coming out as 12.82 meter. Option C is the correct answer. is 12.82 meter will be the height. I hope this is clear. Let us come to the next question. At a certain point, the absolute pressure and atmospheric pressure is given by 850 mm of Hg and 700 mm of Hg respectively. What is the value of gauge pressure? So we need the relationship again between P absolute is equals to P atmospheric plus P gauge. So this P gauge is needed, right? What is the value of the gauge pressure? So it is P gauge equal, wait, P gauge is equals to P absolute minus P ATM, and this is P absolute is given as 850 mm of Hg. Let us take 850 mm of Hg minus, this is given as 700 mm of Hg. So P gauge will be also coming out as 150 mm of Hg. So this is the right answer, 150 mm of Hg, because the unit they need is only mm of Hg. So this is the right answer, 150 mm of Hg. And if they want the answer in Pascal, so we need to like convert that. And how we can convert that? That is rho into G into H, right? So this will be 13,609.81 and H will be converted from 150 mm to the meter, and when we will convert that, we will get the answer in Newton per meter square or Pascal. The next question is saying as the head produced by a liquid of relative density of 1.62 is equals to the pressure of 250 kilopascal. What is the head? Same question अभी अभी जस्ट सॉल्व किए, सेम टाइप ऑफ क्वेश्चन है. रिलेटिव डेंसिटी दिया हुआ है, इसका 1 पॉइंट कितना था 1.62, तो 1.62 रिलेटिव डेंसिटी दिया हुआ है, तो रो ऑफ लिक्विड क्या निकल के आएगा 1620. तो इसका रो हम लोगों को मालूम है. अभी 250 किलो पास्कल दिया हुआ है प्रेशर, तो P इज इक्वल्स टू रो जी H चाहिए. तो ये दिया है 250 किलो पास्कल, तो इसको हम कर लेते हैं इसमें पास्कल में कर लेते हैं. फिर रो तो 1620 है, 9.81 है, और H को निकालना है, तो H विल बी इक्वल्स टू 250 इंटू 10 टू द पावर 3 upon 1620 into 9.81. So if I calculate this, we will have the right answer with us, that is 250 into 10 to the power 3 divided by 1620 into 9.81, and it will be coming out as 15.73. So this is the answer, 15.73, option C. And yes, this is in meter, obviously this is in meter. This is the right answer. I hope this is clear to all. Now this question is saying us a cube of dimension 2 meter is floating in the water with emerging depth of 1 meter. ठीक है. What is the weight of the cube? यूनिट वेट वाटर का दिया है 10 किलो न्यूटन पर मीटर क्यूब. तो ये कंडीशन है, ये एक वाटर सरफेस है, इसमें क्यूब है जो कि डायमेंशन बाई 2 है, उसमें 1 मीटर ऊपर है, 1 मीटर नीचे है. तो द फॉर्मूला इज if a body is floating on a liquid, then we can say the weight of liquid, the weight, so we can say that the weight of the body is equals to weight of liquid into the volume displaced by the body. So unit weight is given as 10 kilonewton. So let us take this in kilonewton only, and the volume displaced will be 1 into 2 into 2, because it is only 1 meter which is sinking and 1 meter which is floating. So 2 into 2 into 1. So it will be 40 kilonewton. So this is the weight of the body. This is 40 kilonewton, and let us check the options. Option D is the right answer, 40 kilonewton. In kilonewton, आंसर भी किलो न्यूटन में करना था, इसीलिए मैंने किलो न्यूटन से न्यूटन नहीं किया, किलो न्यूटन ही ले लिया. 40 किलो न्यूटन will be the right answer for the question. ये बोल रहे कि which of the following is equivalent to 1 kilopascal. So what is 1 pascal? Is 1 newton per mm square. Sorry, 1 newton per meter square. So 1 kilopascal is 1 kilonewton per meter square, which will be 1000 newton per meter square. Option B is the right answer. No, not option B, option A. Option A will be the right answer. 1000 newton per meter square. This is the right answer. Now, what is the equivalent head of the kerosene of specific gravity 0.8 if the head of water is 500 cm? Equivalent head चाहिए water. Okay, so ये rho of kerosene equivalent HK will be rho of water into H of water. तो इसमें दिया है कि केरोसिन का स्पेसिफिक ग्रेविटी जो है 0.8 है, तो इसका मतलब है रो ऑफ केरोसिन जो होगा वो होगा 800. तो दिस विल बी 800 इंटू हाइट तो चाहिए, एंड दिस विल बी 100,000, सॉरी नॉट 100, दिस विल बी 1000 इंटू हाइट ऑफ वाटर क्या है 500 सेंटीमीटर, दैट इज 0.5 मीटर. नाउ दिस विल बी 800, so obviously this will be 5 by 8, 0.625. So height of kerosene will be 625 in centimeter. So this is the right answer, and option D is the right answer. 625 centimeter will be the height for kerosene. And it is given that the intensity of pressure at any point in the liquid at rest is same in all the direction. Is the statement given by Pascal's law? This is given by Pascal's. Pascal's law states that the intensity of pressure at any point in the liquid at rest is same in all direction. So already we have discussed about the Pascal's law. So this is Pascal's law. Option D is the right answer. So next question is saying that what is the depth of the center of pressure for the rectangular lamina which is vertically inside the water of height h दिया है, ठीक है. तो ये vertically inside है, सरफेस है, ये vertically है, और डेप्थ इसका जो दिया है कि ये डेप्थ टोटल ये मान लो h है, ठीक है. इससे ज़्यादा कुछ नहीं दिया है हम लोगों को, इसको निकालना है, ठीक है. तो हम मान लेते हैं, रुको, यस, लेट अस एज्यूम कि ये एकदम सरफेस से ही दिया है, ठीक है. लेट अस एज्यूम कि ये पूरा सरफेस से है, इसका h है अपना डेप्थ, तो सेंटर ऑफ ग्रेविटी आएगा h/2, दैट इज h bar is equals to h/2 है, राइट. एंड लेट अस एज्यूम द एरिया as b into h and moment of inertia bh cube by 12, right. Now let us calculate the xcp, which is x bar plus moment of inertia by area into x bar again and sine square 90 degree. So it will be coming out as h/2 plus B H cube by 12 into B into H by 2, ये तो 1 है, तो H स्क्वायर से जाएगा, ये H रहेगा सिर्फ, B will be cancelled out and this will be 6, so H by 2 plus H by 6, and this will be coming out as 4H by 6, that is XCP and XCP. So this will be 2/3 of the depth. Let us check the answer. Option C is the right answer. So this is the answer, which is 2/3 of the height, right? Now next question, if the gauge pressure and atmospheric pressure at a point are observed as 70 mm of mercury and 750 mm of mercury respectively, what is the value of the absolute pressure? So we need now to calculate absolute pressure. So P absolute is equals to P gauge plus P atm. We already know the equation or the relationship. Now what is P absolute? What is P gauge? P gauge is given as 70 mm of Hg. So let us take this in that unit only, 70 mm of Hg, and this is given as 750 mm of Hg. So P atm is given as 750 mm of Hg, and this is P absolute, which is 820 mm of Hg. So the answer is also asked in the unit of mm of mercury, and that is 820. Option D is the right answer for this question. I hope this is clear. This is nothing but addition only. Now this is the question asking that the rise of mercury in barometer is indicated as 80 mm. What is the atmospheric pressure at that point? So we just what we have to do, we just need to calculate rho gh, and we will have the atmospheric pressure there. So the rise of mercury is given as 80 mm. I hope, is this 80 mm? Yes, this is 80 mm, and we know the rho of mercury. So what will be the pressure intensity there? It will be rho into G into H, and that is 80 mm. We need to convert this 0.008. I hope, no, 0.08, sorry, 0.08 meter, and this will be coming out as 39.81 into 0.08. So P will be coming out as 13,600 into 9.81 into 0.08, and this is coming out as 10,673, and this is in Newton. I hope this will be in kilonewton, right? So if I need, no, I'm just wait a second. This is atmospheric pressure, right? Wait, just a second. So atmospheric pressure in kilonewton at that point will be okay, okay. This is in mm. I think that this will be coming out in Newton, but in kilonewton this will be coming as 10.7673 kilonewton, and this will be coming out as Newton, right? So I hope there is a problem in the question, but according to the answer, this will be the right answer. Option C will be the right answer, right? So this is the right answer. I hope this is clear. Now let us go to the next question. An open tank contains 60 mm of water covered with 30 mm of oil. Specific weight, specific gravity दिया है कि 0.8 है, oil का दिया हुआ है, and the pressure intensity recorded at the bottom the tank is. So according to the hydrostatic law, we have a relationship, that is change in pressure upon change in height will be equals to specific weight. Now the question is, uh, if the h is in increasing manner, that means if I want, if this surface and I am going to downside of the surface, so automatically the pressure will increase with the increase of our height or depth, right? But if I am coming from bottom to top, so our h will be increasing in a height manner, so it will be negative, right? Because the pressure will be decreasing with the increase of height. So if this is measured as height, so this is in a negative manner, but if this is in measurement of depth, it will be positive. So this, in this case, this is given that, wait a second, uh, okay, this is right. I have missed something, I hope. Okay, yeah. So this is a hydrostatic law which I am going to use in the next question, but let me complete once that if I am going down, so if the depth increases, so the pressure is increasing with the depth, and if the height is increasing, the pressure is actually being less, right? So this will be the formula. So if this is for height purpose, it will be minus. Okay, now in this question, it is not actually needed. In this question, it will be, I am coming to the question. I hope there is a question which we will be using. Wait a second. Just a second. Yes, in this question I will be using that uh, principle. And now just solve this question. The first, it is given that the open tank, this is the tank, let us suppose, and this is 60 mm of water is covered with 30 mm of oil. So let us assume this is 60 mm and it is water, and this is some oil which is of 30 mm. So they need the pressure at the bottom, right? Okay, no problem. So here the specific gravity of the oil is given as 0.8. So what will be rho of oil? It will be 800. So at first, let us calculate the pressure at that point. So at that point, will water will exert pressure at the surface? No. Only the pressure at that surface occurred by this well, right? So it will be P1, let us suppose, rho of well into G into this height is 30 meter. Meter or mm? That, okay, 6 centimeter, man, not in mm, not in meter. It is in centimeter. This is also 30 centimeter. Okay, no problem. So this will be 0.3 meter. And if this is 0.3, this will be coming out as 800 into 9.81 into 0.3, and this will be, this will be 2354.4, and at that point this will exert pressure, right? So at that point only water will give the pressure. Then water has a rho of 1000, and let us calculate at P2. It will be 1000 rho G into H. Rho into G is 9.81 and H is 60, means 0.6 meter, and it will be coming out as 1000 into 9.81 into 0.6, and this will be 5886. And if I want the both the pressure, the total pressure, so we have to calculate the total pressure, that is 5886 plus 2354.4, and it will be coming out as 8240.4 Newton per meter square. So this is the right answer. So this Option A is the right answer for the question. Okay. So the next question is saying us that in gauge pressure, the atmospheric pressure on the scale is marked as, so gauge pressure the datum of gauge pressure is the atmospheric pressure only. If this is absolute zero, this is the PATM. So the measurement of pressure from PATM is called as gauge. So if this is absolute zero, this is PATM. So gauge pressure, with the pressure which is measured from this PATM is called as gauge pressure. So option C is the right answer. It is 0. Okay. So in gauge pressure, the atmospheric pressure on the scale is marked as 0. Right. So let us go to the next question. We find the pressure intensity at depth of 50 meter below the free water surface. Take specific weight of water is equal to 9.81 kilonewton per meter cube. So this is a very simple question. The rho is given, not rho actually, they have given us the rho g as 9.81 kilonewton per meter square, right? Meter cube, I hope. Yes, kilonewton per meter cube. Okay, and this depth is given as 50 meter. So if the depth is 50 meter, so it is pressure intensity rho into G into H. So this is 9.81 into 50. It will be coming out as 490.5. But be careful, the unit will be kilonewton per meter square because we have already taken it in kilonewton per meter cube. So it will be the answer. It is 4, what I got, 490.5. Option B is the right answer, kilonewton per meter square. This is the right answer for the question. So the next question is saying that a pressure gauge fitted on the side of tank filled with liquid reads 50 kilopascal and 100 kilopascal at the height of 10 meter and 5 meter approximately. So in this I have already discussed that with the increase of the depth, the pressure intensity is also increasing. So let us suppose this is 10 meter and the reading is saying that this is 1000 kilopascal, and this is 5 meter and this is saying as 50 kilopascal for 5 meter. So we know that with the change of pressure, the dP by dH is equal to specific weight. But in this case, we are going from bottom to top. So it will be like it will be a decreasing in pressure. So we use this as minus sign to avoid the negativity, right? Because we use already the minus because we know the pressure is in decreasing form. So in this case, we can say that let us name this as pressure 1 and let us name this as pressure 2, and this let us name this as H1 and this is as H2. Now can we say that the change in pressure from bottom to top is P1 minus P2 minus H1 minus H2, and this is minus what is the specific weight, that is rho into G, right? I hope this is clear. Now what is P1? Second, what is P1 there? P1 is, no, sorry, let me change the name because the change in pressure will be final minus initial, so P2 minus P1. Yes, and the change in height will be H1 minus H2. Now it will be coming out as, wait a second, it will be coming out as 50 minus 100 by this height is 10 minus 5 is equals to, this is, just a second. Okay, this is already take the G as 10. It is saying that G is given 10. So this will be minus 10 of rho. Now this is minus O. Just one more correction. It is given on kilopascal. So I need to convert this on Pascal. So this will be 50,000 minus, yes. So this will be minus 50,000 minus 5 divided by 5 is equals to minus 10 rho. Minus minus will be cancelled out in this case, and it will be coming out as rho 1000 kg per meter cube. This is the right answer, option C. I hope this is clear for all. Now this is the last question. So this is saying that we need to calculate the pressure. I think it is the CP. They are needing center of pressure. Yes, the answer is needed the center of pressure below the free surface. Now let us calculate this. Like for a triangle, the H bar will be H by 3. Okay, this is the surface and this is the body. So this will be not in the center. It will be the x bar, which is the vertical distance from the surface to the center of gravity, will be h by 3. So h bar is, we have the h bar, that is h by 3. And what is moment of inertia for a triangle? It is b into h cube upon 36. Yes. So this is the moment of inertia. Now let us calculate the HCP. That will be h bar plus IgG by the area into h bar, and this will be sine square 90 degree. Now let us just calculate this. H bar is equals to h by 3 plus this is b into h cube divided by 36. Area will be b into h upon 2. So 2 will be gone to the upward side, and now this is h bar again, h by 3, and this is 1 only. So b and b will be cancelled out. This h will be cancelled with that h cube, that will be coming out as the h, and this is a 2, and this 3 will be going up. So it is, yes, it is 3 is 36. So there is 12 and 2 will be cutting that as 6. So h by 3 plus h by 6. I hope this is h by 3, and if I calculate, wait a second, let me calculate it once. So this is h by 3, this is b into h cube by 36. What is the area? Area is b into h by 2. So this 2 will be sent upward. Now this is h bar, that is h into 3. Okay, this b and b will be cutting out. This 3 into 2 is 6, and 6 and 6 will be 6 here, 8. So yes, it will be h plus 3 plus h by 6. So this 6 it will be 2 h plus h, it will be 3 h by 6, and it will be coming out as h bar. So the center of pressure for a vertical triangle which is at the surface will be h by 2. So this is the right answer for the question, and yes, we got the answer, and that is the completion of our second chapter. So we have already completed 2 chapters, that is fluid properties and pressure measurement with hydrostatic forces. And in the next chapter, we will be start with the buoyancy and flotation, and then we will jump to kinematics, dynamics, and so on. Laminar flow, turbulent flow, every single chapter we will deal with. And I hope that you have liked the video, and if this is at least 1% beneficial for you, just share our video, just like and do comment for the video. And every day at 11 o'clock we have this live class, so you can come live, you can join live, as well as I will be also energetic to take this live class with all you. And I hope this is somehow beneficial for you, and if this is beneficial, so please do subscribe to the channel. And if you have any doubt regarding any question which I am solving, so you always put a comment on the comment section. And thank you for staying with us, like thank you for supporting us, and we need more support. And obviously if you have any doubt remaining in your mind during the class, and if you find any difficulty to understand any question, or you need to you need me to explain the question again, so just give a comment, and in the next class I will be solving the question, I will solving your doubt for sure. And obviously from every day from 11 o'clock 11 a.m. the live class is going on fluid mechanics SSCJE previous year's question. Not only this is a previous year question solving, also some concept will be revised. If you already have completed, you may join the class for just revision of concept. You can practice with me as well, and it will be also a good revision for you. And if you already in your like if you are already going through the fluid mechanics, so it will be also very good and beneficial for you, because some practice of questions will be going on in this session. So I hope you are liking the video, and every day 11 o'clock 11 a.m. we are live in this channel with this particular subject, the PYQ series. So I hope you will be live next day, and if you are watching in a recorded form, please do a like, and let me know in the comment section, are you liking the series, and how are you actually, is it beneficial for all of you. So thank you, have a good day. I would like to say that tomorrow please, if it is possible, come and join the live video if it is possible, if you are free then. So 11 a.m. every single day I will be live, so if it is possible for you, come live, join live, and we will make a better session obviously. So yes, stay safe, thank you, have a good